Here we go. A, which stands for another practice calculus test. All right, go. So f of x equals this, and f prime of 1 is equal to, so take the derivative of that. That's 4 times x squared minus 3 to the third. Don't forget the chain rule. Plug in 1, so we have 4 times 1 squared minus 3 is negative 2 cubed, times 2 times 1, negative 3 cubed is negative 8. That's negative 64. Chain rule, I guess. Big mistake there. Only mistake to make. Number 2. All right, integral. I can do this. So the antiderivative of that, bumping the exponent up 1, divide by the new exponent. So 4 divided by that, right? And you can always check these real quick. Just take the derivative of that. 4, drop the exponent. That make sure it gets you back to there. And that's x cubed. So plugging the 1 in, I get 2 minus 1. Plugging the negative 2 in, I get 32 minus negative 2 cubed is negative 8, so be careful. I'll make a sloppy sign mistake there. So that's 1 minus 32 plus 8 is 40. That's negative 39. That's answer choice C. Number 3, an object moves in the xy plane so that its position at any time t is given by the parametric equations. So these are position. What's the rate of change of y with respect to x when t equals 3? Rate of change of y with respect to x is dy dx. In other words, the slope of the path. Did not say anything about speed, did it? So let's do that. Derivative of this, that's the same as this quantity to the 1/2, so plus 16 to the negative 1/2 times the derivative of what's inside over dx dt is 3t squared minus 6t, and plugging in a 3 into that, 3 squared plus 16 is 25 to the negative 1/2. And then 1/2 times 2, those cancel, and I'm plugging in 3 for t, over, plugging in 3 times 3 squared is 27, minus 18. 25 to the negative 1/2. The 1/2 power means square root. Square root of 25 is 5. The negative sign flips it over to 1/5. Told you need to know how to do this stuff without a calculator. Not kidding. 27 minus 18 is 9. Those reduce. It's 3. 1/5 over 3 is 1/15. That's answer choice B. Snow is falling at a rate of this inches per hour, where t is time in hours since the beginning of the snowfall. Which of the following expressions gives the amount of snow in inches that falls from time t0 to time t equals 5 hours? 0 to 5. This is my rate, so I'm taking the integral there. So the 2 is a constant. Put that on the outside. I'm going to write that as negative 1/10 t, just because. And the beginning of the snowfall, I'm just looking for an initial condition. So at time 0, there's no snowfall. So I don't have to have a plus initial condition here. Excuse me. All right, I need to find the antiderivative of this. So just to be safe, I'm going to do a u substitution here. It's just a linear thing, so I'm going to have to divide by negative 0.1 or multiply by negative 10. But just in case you don't see that right off, I would just do this. So du is equal to negative 1/10 dt. That means I need a negative 1/10 on the inside, which means I need a negative 10 on the outside. So I've got negative 20, and then I'll change my limits of integration from 0 to negative 1/2, right, plugging the 5 into that. And the antiderivative, that's going to turn into e to the u now, as just e to the u. So that's equal to negative 20 times e to the negative 1/2 minus e to the 0 is not 0, so watch out for that. So 20, that looks like that's the same as this. Answer choice D. Some pretty serious math they're making us do without a calculator here. Gotta know how to do that. Can't be paralyzed by that. So finding dy dx, this looks like implicit differentiation, 0.22. So derivative of e to the x is e to the x. Derivative of y is dy dx. Product rule here. That's x times y cubed. Don't forget the product rule. So let's see, that's x, derivative of that is 1 times the second plus the first times the derivative of the second, and anytime I take the derivative of a y, dy dx pops out. E squared is just a number. Derivative, that's 0. Likewise with 18. Don't be a sucker. That's the derivative of that, it's not 2e. Okay, I want to find that at the point xy. So I'll plug in 2 for x. E squared minus dy dx is equal to 8 plus, this is 2 times 3 is 6 times 2 squared is 24 dy dx. So if I add that over here, got 25 dy dx's, and subtract that over here, so that looks like answer choice C. Number 6. On a certain day, the rate at which material is deposited at a recycling center is modeled by the function r. So this is a rate, right? It means the area under the rate gives us the accumulation of tons. Where is measured in tons per hour, t is the number of hours since the center opened. Using a trapezoidal sum with the 3 subintervals indicated by the data in the table, what's the approximate number of tons of material deposited in the first 9 hours? And again, there's no initial condition that I have to add here. They just want to know how much accumulated here. All right, trapezoidal sum. Let's do it. So remember how to do that. It's 1/2, or it's the width of the interval divided by 2 times the sum of these y values. Width is 5 divided by 2, sum of the y values. Sum of the y values. And then we get to simplify that. So that's 1, 15 plus 9 is 24. 5 halves is 14. Half of 14 is 7 times 5 is 35. Plus 9. So let's see what we got here. 9 plus 24 is 33, and 35 is 68. So that's answer choice A. Let's do a couple more in this video. At time t greater than or equal to 0, a particle moving in the xy plane has a velocity vector. So this is the x and this is the y part of the velocity. In other words, that's like dx dt, and this is like dy dt. What is the acceleration vector of the particle? Well, I just need the derivative of each one of those. Derivative of cosine is negative sine of 2t times the derivative of what's inside. So it's not those. And then the derivative of e to the 3t is 3e to the 3t. That was easy. Consider the geometric series, this, where a sub n is greater than 0 for all n. That means the multiplier is positive if they're all positive, right? The first term in the series is a1 equals 48, and the third term is 12. Which of the following is true? Well, if you think about how you get from one term to the next in a geometric series, there's the first term. To get to the second term, you multiply by r. To get to the third term, you multiply by r again, and so on and so on. So if I know that the first term is 48 and the second term is 12, I can actually figure out pretty easily what the multiplier is here, right? I think it's just 1/2, right? You could actually say that 48 is equal to 12 times, that 12, which is this, is equal to 48 How do I want to set this up? Sorry, I don't want to do this in a way that's confusing. So a sub 1 is 48. So this is 48 times r squared, and that we know that's equal to 12. That's what I'm trying to do, right? 48 times r squared, because 48 is the first term, and we know that that term has to be equal to 12. So I almost put the r squared on the wrong side. So dividing there, taking the square root, so r is 1/2. We know it's positive 1/2 because they told us all the terms are positive. So let's just find the sum real quick. Sum of a geometric series is the first term over 1 minus r. That's that. Not bad. Number 9. Function f is defined above. The value of this integral is, well, let's see. Oh, we've seen this before. I'd be so proud of you if you remember what this function looks like. What does it look like? This is the function where you just take a number and you divide it by itself. I mean, x over x, that's just 1, right? Except that if you plug in a negative number, this is the positive version of the number over the negative number. So, sorry, let me say that again. If you're in positive territory, you're just taking a number and dividing it by itself. So you just get 1, 1, 1, 1 all the time, except you can't plug 0 in. And then if you plug in a negative number, you have the negative number on the bottom and the positive version on the top. You just get negative 1 all the time. So what's the value of this integral? 2, 3, 2, 3, 4, 5. If you're thinking that it's non-existent because there's this weird hole there, that's not true. That is not a problem for integrals. It's a problem for derivatives. You can't take the derivative there. So I've got 3 here, negative 5 here. That integral is equal to negative 2. They sure do like that function. Number 10. Which of the following series, actually calculus teachers everywhere love this function because it's not continuous and just lots of fun. Which of the following series can be used with the limit comparison test to determine whether the series, blah, converges or diverges? In other words, that's like saying, remember what limit comparison is? It says this is like. So that's where we just look at the highest exponent top and bottom. And we say, let's see, if the top, we ignore all the other stuff. So this series behaves like the series 1 over n. That's the highest power, top and bottom, reduced. So in fact, we could say that it actually is going to diverge because it's like the harmonic series. But they're only looking for which one is it like. So that's A. If this is in a free response question, we would say, by the limit comparison test, this is like, this one behaves like, so on. Let's stop here.